Hi guys, today we're going to be talking about JavaScript and promises, and I must admit that promises is pretty important topic to understand for many reasons. First of all, in your real life, in day-to-day tasks, you will be encounter promises, and that's for sure. Even if you're trying to avoid promises with all costs, you will be working with promises. For example, if you want to run multiple asynchronous functions at the same time, you want to use something like await promise.all or await promise.trace, doesn't matter, but you still will be encounter promises, and you want to understand the promise, how to work with promise efficiently, and just be good at promises at all. Second reason is that in your next technical interview, most probably you will be asked about promises. I am a trusted interviewer in Global Logic, and I must admit that for many candidates, especially for junior level and middle level candidates, promises is a huge problem during technical interview. And the third reason, last but not least, that to be a good software engineer, you need to understand what's happening under the hood. When you use promises, you want to understand what is on the event loop level, what is on the microtask queue, what on microtask queue, and etc. And when you're using async await, you want to understand what is on the promise level. And if you're using Nest.js or other framework, you want to understand how Nest.js operates with asynchronous functions. So today we're going to be focusing on solving some practical tasks that will help you to understand promises better and will help you to be better prepared for the next technical interview, for next real task. So first of all, I have Node.js version 20.18 installed locally, and I will be using Node.js, but you can follow me and just open your web browser in DevTools and try to do same in the DevTools. So it doesn't matter which Node.js version you're using, which browser, which text editor, so you can just repeat my steps in any convenient way. What would you like? What would you prefer? So I have Node.js and I have opened VS Code where I'm gonna be typing my code. So for example, I'm printing out console.log here, hello, and on the right side I have terminal where I can execute my code. So I have hello. Great, so let's jump to the first problem, and the first problem is the most simple one. We need to implement a function called countWithDelay, and this function accepts two arguments, n and delay. So this function should print out values from 1 to n, and these values should be printed out after specified delay. So for example, we have delay 1 second. It means that we're gonna start counting from 1 to n. After delay, each value should be printed out after specified delay. For example, 1 pause, 2 pause, 3 pause, 4 pause, 5 pause, and we should return a promise and resolve this promise. Okay, I hope it's clear. So here we have an output example. So we need to print out 4 values. Then we should resolve our promise and be able to perform some operation in the end. So here we're printing out done. Okay, so I suggest you to set this video on pause and try to implement it on your own. And otherwise, we can go together and try to solve it together. But anyway, I highly recommend you to try solving it without my comments for now, and maybe you will have some questions, maybe some ideas will rise up in your head, and it will be much more efficient to listen to my comments after that. It will be a high chance that I will cover your questions. Otherwise, you can just leave your questions in the comments below, and I will check those comments. So I will start from the very simple, most straightforward approach. As on each interview, you should always start from the very simple, most straightforward solution that you have in your head, and you just need to describe your thought process. Okay, so I will start from the for loop. I will start from 0 to n, and I will just print out console.log my values here. I plus 1 because we want to start from 1, not from 0. If I execute my function now, I will have 1, 2, 3, 4, and then it will fail because we didn't return a promise. So I'm gonna return new promise. So we know that a promise constructor accepts a function which accepts resolve and reject. We don't gonna use reject here. We want just resolve. And by the way, what do you think if we not resolve a promise here? What will happen if we won't resolve this promise? Now let's try the experiment. So I'm gonna run my problem now. We see that we printed out our values 1, 2, 3, 4, but it didn't stuck. So we expected that our function will stuck and will wait forever, right, to be resolved, for this promise to be resolved, because we chained this callback and we expected that it will be waiting for our promise to be resolved, that as we never resolve our promise, it will wait forever. So the one aspect here that Node.js and JavaScript engine in general doesn't work like that, basically. So it can terminate your application if you have unresolved promises at all. For example, if you don't have any asynchronous operations in task queue, any fetch requests, any open streams or open files, any timers or whatever, it will just terminate the application. This is why you don't see the application stuck or any errors here. But if we call this function resolve, if we call resolve, for example, setTimeout here, and we will call resolve in 9999, we will basically stuck, because it will create a synchronous operation in the task queue, and we will be waiting for this timeout to complete so we can resolve a promise. And basically, this is why on the first case we didn't see that application stuck, and now we see that it's waiting for this timeout. Alright, but now let's just call resolve for now, and later we will come back here. So we see that we have 1, 2, 3, 4, and done. Our function resolved immediately. Great. So the last remaining part here is to add a interval timeout, basically. So let's go with most straightforward solution. I'm gonna set timeout here, and I'm gonna move my console log inside this setTimeout callback, and I will set delay multiplied by I, because here basically we scheduling a set of callbacks in a loop, right? So here basically at the same moment we have a set of scheduling operations, and we scheduling them to complete in a different time. So we want the first one to be finished in 0 seconds, second in 1 second, third in 2 seconds, and etc. I hope it's clear. And now if we try to execute our function, what will happen? We have done 1, 2, 3, and 4. So we saw that we have these values printed out after specified delay, which is what we expected, but done the promise resolved in advance, basically. So what we can do here, we can do same, we can set timeout, and we can call resolve function. Okay, let's actually just call resolve function after delay multiplied by n minus 1. So why n-1? Because we don't want to wait additional second after this for to resolve our promise. We want just resolve it immediately. So let's try to execute it. We have 1, 2, 3, 4 and done immediately, and here we go. So actually we implemented the expected behavior. But let's try to think if we can implement it better. So I'm gonna delete this promise, and I'm gonna delete this set timeout for now. And let us declare our function to be asynchronous function. And we know that whenever we have async keyword, this function automatically should return a promise. So now if we try to execute it, we see that the output is expected. We have 1, 2, 3, 4 and done, so it returned a promise, but we just want to have additional timeout here, so we need to await for some timeout. Okay, so how we can add additional timeout here? We can await for the promise, we can await for the new promise, which accepts resolve. And we want to resolve it after set timeout, resolve delay. And that's it actually. So let's call it 1, 2, 3, 4 and done. And done we have immediately after the last print value. This is what we expected to see. And congratulations guys, we solved our first problem, and I suggest you to solve this problem in a different way after that. So let me create another file here. I call it problem2. problem2.js. And I suggest you guys to implement all the same behavior, but without using async. And instead, I suggest you to create the chain of promises. What I mean by the chain of promises? We know that we can create new promise, and in promise we can print out some value and then call resolve. And if we return another promise in a then operation, basically we will chain a second promise here, and we can do as much as we want chain operations here. So 1, 2, 3, 4, 5, 6, 7, 8. So now if I execute my second problem, problem2.js, we see that we basically printed out values from 1 to 8, but we used promise chain operations instead. So we didn't use for loop, we chained 8 promises together. And I suggest you guys to think how we can automate this operation, how we can create a chain of promises with specified lengths using some algorithm. So it looks like a linked list data structure, right? So we have a node, and each node points out to the next node. And I suggest you guys to implement a function generate promise chain. Again, it accepts an argument and delay. Okay, and when we call the generate promise chain, it should work completely the same. It should create a promise, and we should be able to print out done. Okay, and in result we should see completely the same behavior as in problem 1. So it should print out these values 1, 2, 3, 4 and 5 because default value is 5 after specifying delay. So how we can do that? Again, let's try to create a for loop for let I equals 0, I less than and I plus plus. And here we want to create this new promise. It accepts, again, resolve. Reject we're not using. And in this promise, we want to console.log. Or, okay, we want to wait. So we want to set timeout. And then we want to console.log I. And then we want to resolve our promise. But here we have one problem. Basically, we will create all 5 promises at the same time, and they will be executed at the same time and resolved at the same time. We want to chain these promises one by one. It means that we need to keep track of the current promise and chain previous promise with this one using then operation. So what I'm going to do here, I will create new variable here, current node, which we will initialize with promise resolve, with the resolved promise. In here, I'm gonna say that current node equals current node then. We remember that when we return another promise from then, it will chain our promises together. And in the end of our loop, I will return current node. All right? So what just happened? We created a loop where on each iteration, we save to the current node our next node, which we chained using then operation. Right? So now if I try to execute it, we have 0, 1, 2, 3, 4. We want to improve it. We want to start from 1. And we want to set timeout using delay. Okay, and now we see 1, 2, 3, 4, done. Great, that's what we expected to see. So guys, congratulations, we solved the second problem and we now better understand what is promise resolve, how to chain promises, what is then, how we can use async await with promises and etc. And now we're ready for the real world task. Alright guys, so the third task is more related to the data fetching and real life examples. So here we need to use Pokemon API. It's a free REST API which we can use for testing to fetch some Pokemon's data. So basically here we have a /Pokemon endpoint. Let me present you. So this /Pokemon endpoint is an endpoint which returns us paginated result of available Pokemons and the total count of all Pokemons. And here we need to basically use the count field here. And whenever we do fetch request on Pokemon /1, /2, /3, /4, and etc., it will return us an advanced list of all parameters of some specific Pokemon. All attributes of the Pokemon, so we can, use it as we wish, basically. So the task here is to fetch information about n Pokemons in parallel, but we shouldn't exceed maximum parallel requests at the same time. So basically here we have kind of rate limiting, a technique that is often used in enterprise architecture if we don't want to overload some service. For example, we don't want to start 1,000 of Lambda functions at the same time in AWS Cloud, right? So we want to limit total maximum parallel requests at the same time. Here we're gonna use just fetch request for testing, let's say, but in general, it's a kind of general technique that can be used for any purposes actually. Okay, so the algorithm should be following. We should fetch total count of all Pokemons using this /Pokemon endpoint, then check if number of Pokemons that we want to fetch is higher than the total number of Pokemons. We should throw an exception, right? We should say that, hey, there is total amount of Pokemons is less than you want to fetch, what you want to fetch. And then if everything is fine here, we want to start most interesting part. So we want to fetch Pokemons in parallel, but we shouldn't exceed total number of Pokemons, total number of fetch requests to Pokemons at the same time. So each moment, every second, we shouldn't exceed more than 5, for example, requests at the same time to the API. Okay, so I hope it's clear. And I'm gonna create a new file, problem3.js. I'm gonna paste this stuff here and I will close left side panel for today. I will remove the second call and let's start the implementation. We will start from the most simple stuff. We will fetch the Pokemon's data equals await fetch, and we want to fetch this Pokemon data to get the count value, right? And we want to, let's actually call it Pokemon's response, and we have Pokemon's data equals await Pokemon's response JSON. And let's declare our function to be async function, so we can use async await here. Now, if Pokemon's data count is less than n, it means that we should throw an exception. The total number of Pokemons is Pokemon data count, and you want to fetch n Pokemons. Great. So now let's try to fetch 555 Pokemons, and we received this error. So the total number of Pokemons is 1,302, and you want to fetch 555 Pokemons. Great, so this first step is working fine. Now let's start with most interesting part. So we need to fetch some data in parallel, but we also want to keep tracking of active requests at the same time. So I suggest to create active promises set. So we're gonna use this set just to track current active promises. And we want to create a while loop. While active promises size is less than max parallel requests, we want to create fetch requests and put them into active promises. So let's create const promise equals fetch, and we're gonna pass this second endpoint which accepts Pokemon ID. It's a number. So let's just keep track of active current current Pokemon ID equals 0, and we're gonna increment this current Pokemon ID each time on loop iteration. And instead of number, we're gonna pass current Pokemon ID. Then we want to parse the response, and after that we have Pokemon data. We want to save this data somewhere, and I suggest to create a result map. Why map you will understand later, because initially the idea is to save response data, Pokemon data in some kind of array, but we need to keep tracking all active promises and figure out if this current promise is saved already some data, if it's retrieved data, or we don't have this data in the map. Okay, so we want to put results set promise. We remember that if we use set or map, we can use objects as a key, Pokemon's data. So we saved the result, but we want to push this promise to active promises. We cannot use map because map will contain all promises and we won't be able to control size of active promises. So we have to use separate data structure for that, but it can be improved later. So let's add this promise to the active promises. Let's auto format everything. And what we have now, so basically we filled our active promises set with, let's say, 5 active promises, and after that, after our loop is finished, we want to await for promise that all active promises. So let's say we filled our active promises with 5 fetch requests. We want to wait for all the promises to be resolved here. And after that, we want to iterate for const active promise of active promises. We want to understand if this promise is retrieved some data. So if result get active promise has some data, it means that this promise is already finished fetching data and we need to remove it from the active promises. So active promises, delete active promise. Alright, so this actually executed the first iteration, the first chunk of data. So we've got 5, in this case, we've got 5 Pokemons, and that's it. But we actually want to wrap it in the outer while loop. So we want to do the same. We want to while, wrap it inside the while loop. And we want to repeat this operation unless we finished processing all the current Pokemon IDs. So while current Pokemon ID is less than n, it means that we need to keep going. And the last but not least here, you see that we will always put a chunk of fetch requests, which is will be always the same. It will always be max parallel request size. But in this case, for example, we want to fetch last portion of data, which is less than 5. So I would add another another condition here, so the current Pokemon ID is less than n. So now basically it should keep going over and over while we fetching all the data and push it to the result array, the result map. And after that, we want to get array of data from this result map. So const result array. Let's create array from active result values. So we've got the result, and the last but not least, we want to sort our data because we never know which promise is resolved first, which promise resolved second. It's better to sort this data by the ID. So let's return result array sort, and we have a comparator function here, and we want to sort by ID because ID is a number. Let me show you. So here we need to find an ID. It won't be easy. So here you can see that ID is a number here. So great, we want to fetch 23 Pokemons with 5 parallel requests at the same time, and we want to map data. We want to only show Pokemon name, because it has a lot of information. We won't be able to see anything useful. So I think that's it actually. Let's try to execute and experiment with this a bit. So what we have, we've got some amount of Pokemons, not sure if it's 23. Well, we can count, but actually let's reduce this number to 11, for example. It will be easier to follow. So we have 1, 2, 3, 4, 5, and we have 11 results. So we've got Bulbasaur, we got Charizard and other Pokemons, and it works as expected. So we never exceeded total amount of promises. And let's actually experiment with it in browsers. So I will open DevTools here, and I will switch to the Network tab. And what I want to see here is, so first of all, notice that I have 3G connection throttling, so it will be more straightforward to understand. And second thing, when I call my script, I have enabled waterfall view. Okay, so we see that we've got 5 requests first, then all of them resolved, and then second portion of requests resolved, and after that one last request is resolved. So that is what we expected to see. But there is only one last thing that we can improve here actually. So instead of calling promise.all, we can call promise.raise. It means that whenever any of fetch requests will be resolved, we will trigger our iteration. So let me clear out this console. And let's try to execute it again. So first we have fetch Pokemon data, then we called 5 fetch requests, and you see that our next requests are shifted out. So whenever the first request resolved here, I think this one, the 5th ID is resolved, we immediately started the next request here. When the second request is resolved, we started another one. So this is more efficient approach, I would say. So guys, that's it. I highly recommend you to try to implement it on your own. If you have any questions, please reach out in comment section. And guys, if you keep learning promises, I hope you I promise you that you will be better at JavaScript, you will be better as JavaScript engineer. So, have a nice day and I see you guys in next video.